Next we are going to learn about the time scaling property. Okay, the time scaling means the function t is multiplied with a factor. That's called as scaling. If the function t is subtracted or added, it's called as shifting operation. But if it is time scaling means if the t is multiplied by a factor. Okay, so here the statement is, if the Laplace transform of x of t is equal to x of s, then the Laplace transform of x of a t is equal to 1 by mod a into x of s by a. Okay, here mod a means whether a is negative or whether a is positive. 1 by a, this a at the denominator will always be positive. Okay, so let's look at the proof. The proof is, we find the Laplace transform of x of a t. Alright, Laplace of x of a t is nothing but integral minus infinity plus infinity. We replace x of t with x of a t. X of a t into e raised to minus st dt. Okay, next step is we replace a t with p. So let a t will be p. In that case, that dt will become dp by a. Alright, so I replace a t with p, then I replace t with p by a, then I replace dt with dp by a. Okay, so this by a is a constant, this denominator a is a constant, so I can take it outside. It will become 1 by a into integral minus infinity to plus infinity x of p into e raised to, I can now separate p and I can join s by a, so it will become e raised to minus s by a p into dp. Okay, so this is nothing but a Laplace transform of the function. Instead of s, it is s by a. Right, here you should get e raised to minus sp or e raised to minus st, but here it is now changed to e raised to minus s by a into p. Alright, so we can replace p is just nothing, as long as mathematics, as long as max is concerned, p is nothing but another variable like t. Right, so it will be nothing but e raised to minus s by a into p dp. So in that case, this is a Laplace transform of the function s by a. So this is how it becomes s by a. Okay, so 1 by a into x of s by a. Okay, so this is when a is positive. If a is negative, then I am going to replace every a over here with a negative sign. Okay, minus 80, and here also minus a over here. So in that case, due to this also becoming minus, then when you replace it, this will minus of minus, that is this minus dp will also be taken out. So it will be, so this minus sign of dp will also be taken out. So minus 1 by minus a, this minus minus will cancel, will also become 1 by a. So that means, in other words, whether a is positive or whether a is negative, this 1 by a factor, this a at the denominator will always be positive. This is the equation. That is, the Laplace transform of x of a t is equal to 1 by mod a into x of s by a. Okay, let's look at this example. What this theorem means is that, suppose this is my time scaling property, right? So suppose if a is equal to 2, then the Laplace of x of 2t is equal to, I replace it 1 by 2 into x of s by 2. Right, that means I replace this mod a with mod 2. Mod 2 is 2 itself, and this a becomes 2. Likewise, suppose if a is minus 2, then this will become Laplace of x of minus 2t is equal to 1 by mod of minus 2 is 2 itself. You see, mod of minus 2 is 2 itself. So this is always positive. So 1 by 2 into x of s by a, here is minus 2. So s by minus 2. Right, minus 2. This is how we apply the time scaling property. Okay, so time scaling property is usually applied for signals such as u of t and del of t and all, because in these kinds of signals there is no factor a over here, there is no any constant factor that is multiplied with t. So for these kind of questions only, usually we apply this time scaling property directly. Okay, so we already know for this formulas, Laplace of e raised to minus 80 into u of t. Here also t is multiplied by a factor minus a. Okay, but for these kind of formulas, you don't need to apply the time scaling property, because we are already finding the Laplace transform taking this minus a also into consideration. So that's why we don't apply time scaling property for these formulas. Even over here also, if you can see here, the constant factor as multiplied with t is Ohm's 0, right? So you don't need to apply the time scaling property over here again, because we are already finding the Laplace transform of this by considering the Ohm's 0 over here also. Okay, so this is also the Laplace transform. Okay, so when do we apply Laplace transform? Laplace transform is actually applied for those signals in which is applied for those questions such as this. in this case. Okay, if you look over here, a signal has a Laplace transform of x of s is equal to 2 by s square plus 4s plus 3. Okay, so this is my Laplace transform. Find the Laplace transform of y of t, in which y of t is nothing but x of 2t, right? So here given that x of t is nothing but 2 by s square plus 4s plus 3. Okay, I can factorize this, so this will become 2 by s plus 3 into s plus 1. Okay, so then I write my time scaling property. We know that Laplace transform of x of at is equal to 1 by mod a x of s by a. So here in this example, a is equal to 2, so I replace it with 2. So this will become Laplace transform of x of 2t is equal to 1 by 2 into x of s by 2. Okay, I have already found what is my x by s. I already know what is x of s. Okay, this is my x of s. So I need to replace my s with s by 2. Right? So the Laplace transform of y of t is nothing but the Laplace transform of x of 2t that you have written over here, which is nothing but 1 by 2 into x of s by 2 is replace this s over here with s by 2. So it become 2 by this s becomes s by 2, so s by 2 plus 3, and this s also becomes s by 2, so it becomes s by 2 plus 1. S by 2 plus 1. Alright, so this I can change it when I'm cross multiplying these two. So this will become s1 by s plus 6 by 2 into s plus 2 by 2. This is nothing but 2 into 2 is 4, so this 4 goes to the numerator, so it will become 4 by s plus 6 into s plus 12, which is nothing but 4 by s square plus 8s plus 12. Okay, if you want, you can before I was processing this video, I just want you to pause this video and do this question by yourself and see if you're getting the right answer. Okay, so for these kind of factors only we apply time scaling property. Okay, here also there's another question, also another tricky question over here. See, for example, if they ask questions like find the Laplace transform of this one, del of at minus b. Find the Laplace transform of del of at minus b. Here if you look carefully over here in this signal, there is two operations that's taking place. One is the time scaling operation, which is the factor a, and one is the time shifting operation, right? So two operations are going on in this signal. Okay, so similarly, so for these kind of questions also you should need to apply Laplace transform or time scaling property. Here also, for example, u of at minus b, here also a scaling operation, shifting operation is done. Okay, so how do we do these kind of problems if they ask in the exam? Okay, both time scaling and shifting, both operations are taking place, which means we need both formulas. We need the time scaling property and we also need the time shifting property. Okay, so this is for time shifting property. I have used the value b because I already used a over here. Okay, so Laplace transform x of t minus b is equal to e raised to minus bs x of s. Okay, so from these kind of questions, what you need to understand is you need to find the two values. The two values. First value is what is the time being multiplied by. What is the factor multiplied with t. So here that is very easy. Here you can see that the factor that is multiplied with t is a itself, right? So a is your scaling factor. Okay, so now you need to find what is your shifting factor. So shifting factor, if you look carefully over here, it is written here at minus b. Okay, even though here if you see at minus b, you should understand that this signal is not shifted by minus b seconds. This signal is not, that is, this t is not shifted by minus b seconds. That's a wrong statement. T is not shifted by minus b. Okay, so what is here actually, at is shifted by minus b seconds, not t. at is shifted by minus t seconds. I can only apply the time shifting theorem only if I find the shifting unit of time t, not at. Here at is being shifted, not t. at is being shifted by b seconds, not t. So I can only apply time shifting theorem only if the t is alone over here. So to make this t alone, or to make this factor over here 1, what I do is I take a common out. So this will become del of at minus b is equal to del of a into t minus b by a. right? So this will become in this format. Okay, so here I found out that a is being multiplied. From here I can find out that a is being multiplied with t, whereas my shifting time unit is actually minus b by a seconds. See, t is now shifted by minus b by a seconds. So that means minus b by a is shifted by t. So here I have found my scaling factor, which is a, and my time shift, which is minus b by a seconds. So now I can apply my Laplace transform. Laplace transform del of t, we know it is 1. So therefore Laplace transform of del of at by in correspondence to the time scaling property, it will be 1 by a into 1, which is 1 by a mod a itself. Okay, then I also know, so now I'm going to shift this time by minus b by a seconds. So it will become Laplace transform del of at. So replacing t with t minus b by a. Okay, this is nothing but your given question itself. Laplace transform del of at minus b, which is nothing but as per your time shifting property, we multiply this with e raised to minus b by a seconds, because minus b by a is your time shifting factor. So it will become e raised to minus b by a s by a. Okay, this is how we do this problem. These kind of problems you only apply this theorem, this method, when you are asking given questions like del of at minus b or u of at minus b. Okay, I want you all to do this for homework. Find the Laplace transform of u of at minus b. Okay, I think from here, if you are, I think you can write you can find the answer directly itself from here itself. It is nothing but minus b by a s by s into 1 by a. Into 1 by a, I think into a and a gets cancelled, I think. So you see, I think this is somewhat, I think this is the answer. Just do this as a homework. Okay, I'll find the Laplace transform of u of at minus b and see what's the answer you get. Okay, so now let's do the next question. Okay, let's do this question. Okay, find the Laplace transform of the signal sin omega 0 t plus b into e raised to minus at u of t, where a and b are real, and also find its ROC. I think this they have asked this question in the previous question paper. I think if you check the April 2018 question paper, yes, April 2018 question paper, you can find the same question over there. It's been asked in the previous year. Okay, so let's do this question. Okay, so here given, so here you can see I can here I can change the format of the question here, right? Here it is sin omega 0 t plus b into e raised to minus b. I can take e raised to minus b in the first term, so it will be easy for you to do the problem. So it will become e raised to minus at into sin omega 0 t plus b into u of t. Okay, this term. All right, so here for these kind of questions, okay, here also time scaling operation and time shifting operation is also done, but it is better that instead of applying those two properties, it is better that you split the trigonometric terms, right? We know what is sin a plus b is, right? Sin a plus b is sin a cos b plus cos a sin b. We apply that equation over here. That will become the problem become much more easier. Instead of applying the two operations, it is better you split the two sign terms. Okay, then the problem will become more easier and the answer will be more correct also. Okay, so here as you can see from the, how do you find the Laplace transform of this kind of question? First, I have told you earlier that if you see this kind of an exponential function with t as the power, e raised to minus at, immediately you should understand that this question you are supposed to apply a frequency shifting theorem. You're supposed to apply frequency shifting theorem because of the exponential function over here. From that we can understand which property you need to apply. Okay, the frequency shifting property. So we like that first. We know that the Laplace transform of e raised to minus at into x of t, e raised to minus at into x of t is nothing but x of s plus a. This is the time shift, this is the frequency shifting property. Okay, so here you see e raised to minus 80 is the multiplied over here. So what is my x of t? This whole term is my x of t. Alright, so here x of t is equal to sine omega 0 t plus b into u of t. Okay, so instead of applying the Laplace transform to this, let me simplify this, okay, by expanding this sine term over here. So this will become sine omega 0 t into cos b plus cos omega 0 t sin b into u of t, okay. This is also equal to multiplying u of t inside this bracket, sine omega 0 t into cos b into u of t plus cos omega 0 t sin b into u of t. Okay, so now I am going to find the Laplace transform. Now this will become a very easy problem for finding the Laplace transform. So a Laplace transform of x of t is equal to nothing but Laplace transform of this plus Laplace transform of this. So that means the Laplace transform of sine omega 0 t into cos b into u of t plus Laplace transform of cos omega 0 t into sin b into u of t Okay, so here cos b is a constant. See, there is no t inside this term, there is no t, so I can take cos b as common. So this is nothing but cos b into Laplace transform of sine omega 0 t into u of t plus, here also see sin b is a constant, so I can take sin b outside, so it will become sin b into Laplace transform of cos omega 0 t into u of t Okay, so we know what is Laplace of sin omega 0 t into u of t. It is nothing but omega 0 by s square plus omega 0 square. Likewise, we also know the Laplace transform of cos omega 0 t u of t. It's nothing but s by s square plus omega 0 square. So this is nothing but cos b into omega 0 by s square plus omega 0 square plus this is sin b into s by s square plus omega 0 square. This is the Laplace transform of x of t, right? The Laplace transform of x of t. Okay, so now we found the Laplace transform of x of t. So this is my x of s, right? This is my x of s, right? So now what I am going to do is, in order to complete this answer, I am going to replace s with s plus a, right? So therefore the Laplace transform of e raised to minus 80 into x of t e raised to minus 80 into x of t is what? It is sine omega 0 t plus b into u of t okay, is nothing but here I'm going to replace just over here. Here you replace x of s with x of s plus a by changing the value of, while changing the function, replacing the function s with s plus a. So wherever you see s over here, you should replace it with s plus a. So this will become cos b into omega 0 by s plus a the whole square plus omega 0 square plus sin b into s plus a by s plus a the whole square plus omega 0 square. So this is your final answer. I can combine these two terms because the denominator is same, alright? So I can write this as s plus a the whole square plus omega 0 square, okay, and numerator is omega 0 into cos b plus s plus a into sin b, right? This is your answer. So now we found the Laplace transform. So now we go to find the ROC, the region of convergence, okay? So that is also very easy, okay? If you have understood thoroughly if you have really understood how to find the ROC, you can simply say that the real part of s is greater than minus a. You can simply write that equation. It's if you understood how you found the ROC. If you have not understood, then you can just listen to it right now. Here, to find the ROC, we know that we have to find the value of s, right? That is, we need to find the poles of this. So here, if you look over here, this is my equation. That is s plus a the whole square plus omega 0 square equal to 0. This is the pole. This is the equation for finding the pole, right? So here we know this is a square plus b square. So how can I split this term? This term can be split by writing it like so: s plus a plus j omega 0 into s plus a minus j omega 0 equal to 0. So my poles are s is equal to minus a minus j omega 0 and s is equal to minus a plus j omega 0. These two are my poles, okay? So now I want to find my real part of s. What is my real part of s? What's the equation for s? S is sigma plus j omega. J omega or j ohm? J ohm. We have studied as j ohm, so we write j ohm itself. Right? So here if you compare these two equations, you can find that the value of sigma is minus a, or that means the real part of s and the pole of the real part of s is minus a, right? So here if you can see that this is a right-sided signal, see the signal is multiplied with u of t, so this is a right-sided signal, so immediately I can understand that the real part of s is greater than minus a. That's how I got the ROC. Real part of s is greater than minus a. Sigma j ohm 0 minus a. So greater than. So this is my ROC. See, this is how we do the problem. Okay.